Hello Tachyons, this is Kumar and welcome to the TachyLab. We are doing motion, forces and energy, and in this unit particularly we are covering physical quantities and measurement technique. This is lecture number 3 and the final one. Today we are going to discuss the period of a simple pendulum. Yes, so what is a pendulum? So in pendulum you can see it is this type of arrangement where you have a stand, a clamp, string, a metal bob, a stopwatch and a meter rule. Stopwatch and meter rule basically for the measurements. So what is our aim here? Our aim is to determine the period. Period means the time and the frequency of a simple pendulum and investigate factors that affect its period. Now see. So before starting with that, we should know what is an oscillation. So oscillation is one complete to and fro movement of the bob. So here we can say if it starts from A to O to B, and then again return back to O, and then return back to A. So this whole movement A to O to B, B to O to A, that is one oscillation. Now sometimes we can also start from O. It doesn't matter from where you're starting. It's just you need to end at the same point. So if we are starting from O, it would be O to A to O to B, B to again O. So here's where we have to stop then. I hope this is clear. So this will constitute one complete oscillation. So in this A and B points where the bob is basically reaching its maximum height, so that is the extreme position, and the center one, the O, that is a rest position. Okay. Now comes what is time period and frequency. So we have to measure this. So we should know that. So for that one complete oscillation from A to O to B, B to O to A, that complete oscillation, the time that it took, that is known as the period. And how can we find it? Now say if we are going to take one reading, we might not be able to just find it out accurately. So we take couple of readings, and then what do we do? Time period is the total time taken for those many readings. Let us say 20 oscillations, divide by number of oscillations. Okay, so let us say for 20 oscillations it took 30 seconds, and how many oscillations were there? 20. So that's how we will be able to find it out. And what is the frequency? Frequency is number of oscillations per second. So in 1 second, how many these oscillations are there? That is the frequency. It is basically the inverse of the time period. I hope this is clear. Now comes why time several oscillations. So again, why aren't we taking just one oscillation? Why we have to take 20 or 30 oscillations? Because of the effect of reaction time error. So when we are starting and stopping the stopwatch, it takes time because it is a human reaction, right? So it's better that we take multiple readings and take average of that. Now what happens to the amplitude? Now what is the amplitude? That maximum height that the bob was reaching. Now see, it will go like this, come back, and then complete, and then now it's not going to the same height. It's a little bit down, and then it will continue. So it will be like this. And then ultimately it will just come to rest. So you see the maximum height, it's not reaching after that. Why? It's decreasing. The amplitude is decreasing because of air resistance and the friction. So the bob will eventually come to the rest. Now investigating the period, investigating the time. Now first is effect of the string length, that how it affects it. So in this we have three kind of things that you need to know. It's also important for your future purpose. Independent variable, dependent variable, and control variables. So independent one is what you are going to change, like the length of the string. So this is what you are changing. And what is dependent? Dependent is what you are going to measure. We have to measure the time period. So time period is the dependent variable. Then comes controlled variables. This is something that we are going to keep same. to keep all of the test fair. So we have to keep it same, like mass of the bob or initial amplitude, apparatus we have to keep the same, and same method of timing. So control variables is something that we have to keep the same. I hope this is clear. So now how we are going to investigate the period, what is the method? First of all, obviously we have to set up the whole pendulum and choose a particular length, right? And now we have to put a bob, and we have to give it angle and then release it. And without pushing, we don't have to give it any force, we just have to release it. Okay, and now we will measure the time. We will use this stopwatch to measure the time for 20 oscillations. We are going to repeat this experiment. We will find out the average time and the time period. And now we are going to change the length. Remember, we are going to change the length of the string. So here we are going to repeat the same experiment over and over again for different lengths of the strings. And then we are going to compare the results. And what does we find out? We find out that, okay, longer string means longer time period. So the time is going to increase with the increase in the length of the string. If we are going to decrease it, the time period will decrease. This is one result. Now coming to the next effect. So we are going to see the effect of the bob mass, right? So this pendulum bob that we are using, we are going to change its mass, like 1 kg, 2 kg or a few grams. We are going to change it. Okay. But what we are going to keep constant now, in the previous one, it was the string length that was changing and mass was kept constant. But in this, the string length will remain constant. So string length, amplitude, release method, everything else, that will remain same. It is the mass that will change. Okay. Again, we have to apply the same methodology. The only thing is, now we are going to use the bob of different masses for different readings. Okay. And again, we are going to note down the time period, and then we are going to compare the results. And what does we find out? That mass of the bob does not significantly affect the period. So time period does not depend upon the mass of the bob at all. Okay. So for string, it depends. It will increase, the time period will increase. But in case of the mass, it doesn't affect. It will remain same if the length of the string is same. Now comes systematic errors. Now there are errors and you cannot avoid it. There are different types of errors, and one of them is a systematic error. So this is the error basically. For example, you have this ruler here and you can see I ask you to, okay, measure the height of the point P. So you will measure it, right? You are using it and you measure, and suppose you give me reading 5.9. Now you will be like, oh, this is correct, 5.9 centimeter, but in reality this is wrong. Why? Because you see this, where does this measurement go? No one is measuring that, because the length that you're telling me is starting from 0, is not starting from the very bottom. And this is height x here. So we need to add this x with every reading to get the actual height of the points. So you see that how the error is shifting all the results in the same direction. So it will actually be 5.9 plus x centimeter. This is the actual height. I hope this is clear. So suppose even if you take the reading 4 here, it will never be 4 centimeter, the height. It will always be 4 plus x. So x we have to keep on adding up with each value. If you're liking my way of teaching and you're able to understand, do like the video, share it with your friends. For free notes, do check the link in the description. And if you want to join and know more about one-to-one and small group classes, again, contact us. Now we have two more important things to discuss here, that is the vernier scale and the screw gauge. See, we have the simple ruler and other meter scales or what, and they are useful. It's not like they are not useful. But the thing is, they are not able to give us the readings which are more precise than that. So we have vernier caliper, which is used to measure lengths more precisely than a user. And that is the very reason why we're using the vernier caliper. And usually a meter scale or simply a ruler that we use, that can measure up to 0.5 that can measure up to 1 mm. But Vernier scale can measure up to 0.1 mm or 0.01 centimeter. Again, accurate. Then, how does the Vernier scale work? A Vernier scale has total 10 divisions over 9 mm. That means one Vernier decision here would be 0.9 mm. This is important to note down here. That means how we are going to solve it, how we are going to actually measure it or read it. See, there are two readings with the main scale and the Vernier division, right? This is the Vernier scale. So this is the object and we need to measure the length of this object. Let me change the color. Yeah, so this is the object and this is the length. And we need to measure OA, right? We need to measure this OA. Firstly, we need to read the main scale, find the zero of the Vernier scale and note the main scale reading just before it. We need to find OA and we need to measure the Vernier scale, the main scale reading, and then find the matching Vernier division. So the point where the lines exactly line up the mark, that's what we have to take. So here if we have to measure OA, it will be OB minus AB. So in this OA is equals to, now OB is how much? This is 1 and this is 2. So this is 1.9. How much? Centimeter. Minus. Now AB, how many divisions? Now we have to take the Vernier division. So 1, 2, 3, 4, 5, 6. Total 6 divisions are there. So it will be not just 6. We have to multiply it with 0.09 centimeter as we just discussed. So 0.09 centimeter. So OA gives us 1.9 minus 0.54 and this gives us 1.36 centimeter. This is the reading. I hope this is clear. And then calculate the reading by subtracting these. So we have to subtract the main scale reading and the Vernier correction. So this is the same thing. Like OA is equals to OB minus AB, right? So OB is the main scale reading and AB is the Vernier correction. Moving to micrometer screw gauge. Now, why do we need a screw gauge? So now this gives us even more precise values. So this is used to measure very small objects with high precision. And now how much precise? Up to 0.01 mm or 0.001 centimeter. So this is even more precise than a vernier caliper. Now in vernier caliper, we can see that where we have a shaft scale, we need to measure the main reading and we need to measure the drum scale that will give us the smaller measurements. We have the jaws, these to hold the object and friction clutch to grip the object. Now, next, now again, how to read a micrometer. So we need to take the readings, different readings. So first is the shaft scale. Okay, this is the shaft. So we need to measure this. Then we have drum scale. So you see this drum. This is the scale. We see these lines here. This is the drum scale. Then we need to add both of the readings to get the answer. And here is the object in between these jaws, these shafts. I hope this is clear. So we can see that shaft reading, if we take, if let us say this is 2, and so it will be like 2.5. This is in millimeters. And then we need to add drum reading. Now, what is the drum reading? If you see, this is 30 and this is 35. So it's in between and it's coinciding. So let us say it is 33 divisions. But we don't have to take 33 directly. We need to multiply it with what? With 0.01, how much? Mm. So it will become 2.5 plus 0.33. So it will give us 2.83 mm. So this is the actual reading. This is the actual here width of the object. Now we have two types of quantities here, scalars and vectors, scalar quantities and the vector quantities. See, scalar quantities are the one in which we are going to measure the magnitude only. For example, I say distance. So if I covered like 10 meter, so there is no direction, only magnitude, that is 10 meter. It's a scalar quantity. Then we have vector. Vector means we need to have the magnitude plus we need to have the direction. So it's like I have walked 10 meter east. So 10 meter giving us the magnitude and east is giving us the direction. So that's a vector. So in scalar, direction is not required. In vector, direction is essential. And it is described by number and a unit. But in case of vectors, it's magnitude, unit and direction. So now scalars can be added like ordinary numbers. For example, I traveled 20 meter and then again 20 meter in some other direction and then 20 meter in some other direction. So what is the total distance? So it is 20 plus 20 plus 20, that is 60 meter. That's it. I just added them. Nothing else. But when it comes to vectors, direction will be considered. So we cannot simply add them. They can be added or subtracted only when they are in the same direction or in the opposite direction. Otherwise, there are different ways. And if suppose the body started from point A and somehow it just returned back to point A, same point, right? So its displacement will be 0 because it just came back. But let us say now if the vectors, instead of being in the same direction or in opposite direction where you can add and subtract, let us say they are making 90 degree with each other. So here you see that we have two vectors A and B and they are making 90 degree with each other. And we need to find out the resultant vector. So how do we find it out? See, this length, this is equal. So that means the other side also it will be equal. This is also B and this is also A. So we have this triangle now. So we can use the Pythagoras theorem, right? So what does Pythagoras theorem says? Hypotenuse square is equals to perpendicular square plus base square. So hypotenuse is the resultant square and it is A square plus B square. So resultant is A square plus B square whole under root. And now what about the direction? It's a vector, we need to tell the direction, right? So direction is basically the angle at which the resultant is. Now you can find it with respect to A or with respect to B. Let us say if we find it out with respect to A. So tan theta here is perpendicular by base. So perpendicular is B and base is A. So tan theta would be B by A. I hope this is clear. Let us solve a question now then. So we have to find the resultant of the two forces. One is 3 Newton and other is 4 Newton acting at right angle to each other. So here is the diagram. We need 3 Newton, we need 4 Newton and they both are making 90 degree with each other. And the resultant would be the diagonal of this parallelogram or a rectangle. So we know the formula directly. We can use that. So F square is equals to 4 square plus 3 square, which is 16 plus 9, that is 25. So F is equals to under root of 25, which is 5 Newton. 5 Newton. Now comes tan theta. That is perpendicular by base. Again, what is perpendicular? It is 4. And what is base? That is 3. So we can find it out and it will come out to be 1.3. So what is theta? Theta is tan inverse of 1.3. So theta comes out to be 53 degree. Theta comes out to be 53 degrees. So the resultant is 5 Newton and it is making 53 degree. 53 degree with what? With 3 Newton force. So this is how we can find out the resultant for two vectors which are perpendicular to each other. I hope all of you are enjoying the lectures and actually understanding the concepts. And if you do, then do like this video, interact with it, do tell me in the comment section. And if you need any other particular topics for me to cover, just let me know. I'll do cover it. Thank you so much. I'll see you in the next class with questions.